In this lesson, we're going to solve quadratics by using the quadratic formula. And the quadratic is going to need to be in standard form, so ax squared plus bx plus c. This is the quadratic formula. It is x equals, because it helps us solve, so we're looking for our x's, and x equals negative b plus or minus the square root of b squared minus 4ac, that entire numerator divided by 2a. So don't just divide the square root by 2a, it's the entire piece divided by 2a. So, good news about the quadratic formula is it will solve every quadratic regardless. Doesn't matter if it's factorable, doesn't matter what the situation is, it will solve all of them with no exception. Bad thing about the quadratic formula is you gotta remember the formula. You gotta use the formula, you gotta know your order of operations, make sure you use it step by step. But it will work, and it'll get you your answer every single time. So, we'll start off with a quadratic, and let's see if we can solve it. So, very first thing is we need to rearrange this so it kind of it's in our standard form. So we want to usually ideally leave the x squared term positive, so we'll bump the 2 over, which will make x squared plus 4x, and it'll make it a minus 2, and if we move it over, there's nothing left on the right side of the equation. So if we could factor it, I would try and factor it. So the question would be, is there anything that multiplies to negative 2 that adds to 4? And the answer is going to be no. So we need to use the quadratic formula. So quadratic formula is negative b plus or minus square root b squared minus 4ac, all divided by 2a. So I'm going to do just this term inside this square root for a second. That's known as the discriminant. So I'm going to pull that to the side just for a sec and not have to rewrite this over and over and over again. I'm just going to get that value. So our a is a 1, our b is a 4, and our c is a negative 2. So it's going to be 4 squared minus 4 times a, which is 1, times c, which is negative 2. And so this will be 16. We have a negative and a negative, so that'll be a positive. 4 times 2 is 8. So that turns out to be 24. And if you watched the video about the discriminant tells us a little bit about the visual and a little bit about what our answers are going to be. We're going to get 2 real solutions here, and we're also going to get 2 x-intercepts. So when we check it, we should correlate to our solutions of having 2 x-intercepts because we have 2 real solutions. All right, so let's plug in the values now. Our negative b is going to be a negative 4, plus or minus. We've already done the discriminant, the term inside, that makes a 24, divided by 2 times a, which is 1. So we want to try and simplify this down. Square root of 24 is not a perfect square. However, there is a perfect square that I can divide out of it. So 24 can divide out of 4, and 6 would be the other value. So I'm going to rewrite that now. So x is going to equal negative 4 plus or minus. Square root of 4 is 2. Square root of 6 does not have a perfect square. It's not a square root. I can't square root it. So I just leave it like that. 2 times 1 is 2. So now we're going to try and simplify this. And each of those values is divisible by 2, which means we can simplify it. So we'll divide every single one of those by 2. So we'll get a negative 2 plus or minus. So that would become a 1, that would become a 1, that would become a 2. So negative 2 plus or minus, I don't need to write 1 square root 6, I can just write square root 6, and I don't need to write divided by 1. So those are our 2 answers, because one of them is negative 2 plus square root of 6, one of them is negative 2 minus square root of 6, which is not easy to plug back in and check it, but remember that these are our x-intercepts as well. So I would plug them in the calculator, get the decimals, graph this one, when it's set equal to 0, and see what the x-intercepts are here, and see if it matches our decimal values. And really it's a spot check, because you're probably not going to get if you mess up on it, it's going to probably be fairly off. So find your approximations and see if those match the x-intercepts here. All right, let's do another one. So we have, I'm going to put this on a separate board. Okay, so second one. We have 5x squared equals negative 10x plus 3, or minus 3. Right at the very beginning, I don't like the way it looks. It's not going to help us with quadratic formula until we get everything over to one side. I like that that's positive, so let's leave that there, which means these two terms need to come over. So 5x squared, we'll bump that piece over, it makes it a positive 10x. Bump that piece over, makes it a positive 3, and now equals 0. Quadratic formula is ready to go. So our formula is negative b plus or minus square root of b squared minus 4ac, all divided by 2a. And I keep writing it down until I know I got that thing memorized. But I just like to kind of organize it by rewriting it every time, plug in the values. But we'll do the discriminant part, piece inside the square root first. So our b value is 10. So it's 10 squared minus 4 times a, which is 5, times c, which is negative 3. Oops. It's a positive 3. And then we have 100 minus, we don't have another negative sign to cancel it. We have 20 times 3, which is 60. That becomes 40. So now we're ready to plug everything in. So it's negative b, which is negative 10, plus or minus the square root of 40, divided by 2 times 5, because our a value is 5. All right, square root of 40. There is a perfect square we can take out of that, which is 4. And 10 would be the other factor. And 10 we can't square root, nor does 10 have a perfect square that we can divide out. So we rewrite this, and so x is going to equal a negative 10 plus or minus. The square root of 4 is 2. Square root of 10 we can't do. All divided by 10. So again, we're looking at all these numbers on the outside. And it's either all or nothing. They're all divisible by something, or we can't simplify it at all. So they're all divisible by 2, which means that becomes a 5, that becomes a 1, that becomes a 5. So our final answer is negative 5 plus or minus the square root of 10 divided by 5. And again, I would change these into decimal approximations. These are the exact answers. So you have a negative 5 plus 10 square root of 10 divided by 5, and you have a negative 5 minus the square root of 10 divided by 5. So those are two different answers. I would turn them into an approximate and figure out right from the beginning here, the discriminant told us we were going to get 2 real solutions. We did. And we should have gotten 2 x-intercepts. So if we graph that equation right here, we should have 2 x-intercepts, and they should be the approximate, the decimals. All right, let's do one more. So if we have x squared plus 1 equals negative x. Again, I don't like it. We're going to need to rearrange it a little bit. Leave the x squared positive. We'll bump this piece over. So that's x squared. This would become a positive x plus 1 equals 0. Quadratic formula is ready to go, because again, we should have tried this over here of trying to factor it at this point. You could try it, but sometimes it's not even worth trying it and it ends up taking you longer. If it takes you more than about a minute to factor, don't even bother. Just throw it into the quadratic formula. It's going to take you just as long. So ends up being a little bit more efficient actually sometimes. So is there anything that multiplies to 1 that adds to 1? No. So this is not factorable. So we have to use quadratic formula. So negative b plus or minus square root of b squared minus 4ac, all divided by 2a. Let's do our discriminant. See what kinds of solutions we're going to get. B squared minus 4ac. Our b is 1. So 1 squared minus 4 times a, which is 1, times c, which is 1. So that's 1 minus 4 is negative 3. We're going to get 2 imaginary solutions. All right, so where's that going to come from? Well, you're about to see. And also we have no x-intercepts. So if you graph this equation right here, you're not going to have any x-intercepts. So when we get our solution, all of that should correspond together. So let's plug in our b. Our b is a 1, so it's a negative 1 plus or minus square root of, we've already done that math, negative 3, all divided by 2 times a, which is 1. So x equals negative 1 plus or minus, so we're trying to simplify this. We can't square root 3, and we really can't square it a negative. All we can do is represent the square of a negative with an I. So it's I square root 3 divided by 2. So, 2 imaginary solutions, it's because we had a negative inside the square root. That's what that was going to happen. That was going to make that happen. So here's our imaginary, and this doesn't show up. So if you graph this equation, you shouldn't get x-intercepts because imaginaries don't show up on those types of graphs. And so that's our solution. And there's our 2 imaginaries. One is negative 1 plus I root 3 over 2, and the other one is negative 1 minus I root 3 over 2. All right, and that was solving quadratics by using the quadratic formula.